Well, we're living in a very exciting period of engineering, exciting and very interesting with all these AI innovations around us. We're all feeling it, we're all doing it. The moment that you hit that tab button or the enter button in your cursor chat, and suddenly out of nowhere, 40 lines of code appear in your code file, which is well indented and syntactically correct, and everything looks great. It feel like magic, right? It feel like finally we have the easy button for engineering to become more productive. And yet we can also see the output recently that we ship more code, we fix more bugs in Jira than we used to do 2 or 3 years ago. Well, AI does make things faster. You can generate now a boilerplate, refactor a massive functions, or even get the architectural decision suggestions within seconds. And it looks great. It does look great. It does give you a feeling, a great feeling when you can actually move things faster. But here's the questions for me to you from senior to senior. Do you actually recently feel like you have more control over your code base with all this AI support? Or do you feel like you become more and more like a high speed proofreader rather than an actual coder? My name is Maya, and this is Build with Maya podcast. Today, we are going to discuss about the most common AI claim recently, the idea that AI is making engineering easier. It doesn't, it make it faster, that's the fact. And if you are if you know how to try, you probably knows that the faster you go, the harder you can control the steering wheel and not go off-road. Today we're going to talk about how our jobs have shifted from being an authoring with full control to being an auditor. Okay, so let's talk about the old days first. The old day when we don't have all these AI tools that help us to go faster. So in the old days, when you receive features to implement, it usually takes time. It takes time for us to understand the code base, to navigate around the code base, tries to understand the connection between the components to component and how the data will transfer between the system, API to server, and so on and so forth. And with that, usually we will start implementing by typing. We type in our logic, and when we type, we don't just type, we actually process, and our brain start to process the idea, the solution we have in our mind, and trying to, what you call it, simulate the result, the output of what we type in as we go. And then it will try to figure out whether this makes sense or whether it shouldn't be there or not. And that was fine, right? And we actually took it for granted. We actually feel like it slowed down a lot because we have to type and we have to figure out on the way, we have to compile ourselves trying to think that whether our solutions works. But nowadays, with all these AI solutions that helping us to generate answers within seconds, things change. We no longer need to type anymore. And the answers we got from AI, the suggestions that we got usually is very fast. It's like 200 milliseconds. And with this bit, our brain wouldn't be able to have enough times to simulate everything. It would not be able to have time to simulate the why the solutions is there, why it will implement like this. Instead, it's only have times to do one thing, evaluate the how, which means it try to understand how these solutions were implemented and to evaluate whether it makes sense or not. And this is where the traps begin. Because we as senior engineers have some kind of like a bias towards the well-structured, well-defined looking code. And AI generated code that is well-defined, it according to best practice by definition. It follow the style guide. It do indentation perfectly from the first time, and it even get the naming convention, which is the hardest part of our engineering life, correct, much better than us. And with that, when we see their code, when we see their solution that presented by AI, our brain automatically get biased and relaxed because the code is so well structured that it make our brain start to immediately fall into the bias thinking that since it's organized, it must make sense, right? It must work. It sound logic, but it not. So AI knows the syntax. It does know all this best practice on the clean code approach, but it doesn't know the whole picture, the whole context. It know how not to use effect in React applications because it's just not considered good practice, but it doesn't know the specific requirement for latency in your feature requirement, or it doesn't know that uh, your database is actually accepting none value as the valid value, but it doesn't accept undefined as the valid value, and you need to handle it specifically, gracefully in your code. So that's the shift. Instead of spending 80% of our time writing the code, evaluating this in our brain automatically, and then spending 20% of reviewing the code and doing the additional organizing the code to make it work, now we actually spending 5% of our time writing the prompt to get the solution back, and 95% of our time evaluating the solutions that we receive. And that's caused a significant change in the way we work. So instead of the normal workflow where we take um, piece by piece, brick by brick, and build it together, assembly it together to build the whole wall for as our solution. Now we move into the workflow called evaluation workflow, where we receive the ready-made wall and we have to use our own magnifier to audit, to inspect, to debug, to see where is the piece of brick that can cause the whole one collapse, where the crooked piece of brick, or where's the crooked combination of bricks that may destroy the wall in a certain situation. And guess what? I promise you, finding a crack on the ready-made wall is way, way harder than finding the crack it right there when you pick the piece of brick and plug it into your system as you go. That's just almost impossible. Let's take an example to understand this further. So recently, I was working with my teammates and a senior developer on fixing a small bug on the UI. Well, it's turned out the bug is not as small, and we have some issue with the data transfer between the UI and reactivity system to the engines that run in the application. So the UI component doesn't react when another UI component change, and we don't know why. It only a very specific use case. In other use case, it does react when the other component change. It's just with this specific data set, it doesn't react at all. And the senior dev who working on the bug, he used Cursor to generate to generate the solution, and the solution was 20 files code change PR with over 100 lines of code change. Because the reason is that the AI suggests to do a few refactors on the current reactivity system that that doesn't react well when you have a different data set will pass to these two components. Okay, it passed the linter, it passed the unit test, and even on the manual testing, it works at the first glance of it. But the problem is that it's introduced another hidden complexity right here, that the senior dev actually have to refactor the whole reactivity system to support this specific case, but he doesn't really know if there's any crack that can happen with this solution. Because when you refactor something, you introduce a regression's potentials right there unknowingly. So one of the questions I asked this dev is, explains to me how the solution works, where, how the flow, how the reactivity system connect to each other, how we talk to each other, how we talk to the engines, and why there's corrupted data only on this specific case. The dev couldn't answer it. If he would have implemented the solution by hand, he would be able to at least answer some of the questions, because he will have to understand the flow and the connection between the reactivity system to the main application engine and the data that passing through the pipe here. But he wasn't. He was using AI to help him with that. So he didn't have to type the solution. So his brain was not forced to think through the whole flow step by step. And with that, he wasn't able to understand fully what the solutions give you, what extra side effect it give you without him knowing it. So instead, in order to answer my question, he spent more times debugging, hours debugging on the solution in different case, in many in like a full regression, just to understand. And in this case, fast coding solution together with a long slow debugging time spent on the solution doesn't really give you any gain. It actually makes you lose time. It makes you lose valuable time that you can spend on other things. And now, you know what? You even have to you have to debug codes that you don't write, and that's annoying, because you debug the code you don't write, you don't fully understand why it's code like this, so you have to go step by step to understand why solutions were implemented like this. And that gave us a very scary situation. Before, when we are a senior engineer, it means that our value is also not only about how we write code, it's also about how well experienced our technical background, which means it's like you can call this like a muscle training. We don't train by remember all the syntax. Most of the time, I don't even remember half of the JavaScript syntax. I just use Stack Overflow to find the right syntax on Google search to get for me the right API syntax. I just know it there. But I know I have the technical knowledge in order to know when to use it. And with this new AI agents or buddy, you losing this specific skill. You get your technical background, your technical skill by training, by learning, by writing code, by simulating your brain different situation. Now instead, you spend 8 hours a day to be the compiler of the LM generated code. You're not practicing architecture. You actually practicing proofreading when you have to read through the code generated by AI and try to figure out how it works, or even have to debug line by line to understand, to compile it and debug line by line to understand if there's any side effect it may cause. And it ruined the whole technical expertise for you, because AI doesn't have the seniority feeling. It only have the probability settings, which means it would know that probably this solution will work and how much confidence is A in the solution. But probability is not engineering. So if you ever have to spend times the whole day on debugging on something, some solution generated by AI, you probably know what I'm talking about. The human compilers are not cool, because once you become a human compiler, when you that means you are developing a proofreading skill, which is good for fast reading, but you are losing the other skill, which is your technical skill. And if you losing your technical skill, it makes it even harder in the long term when you have to proofread AI generated solution further and further. And that will be the downhill for us. That will not give us the control that we want, and we destroy our works in the long term. So okay, so how do we survive this? How are we going to solve this problem? How are we going to use this tool without losing our expertise, our edge, and have more control in our code base as we want it to be? Well, we need to move from the normal sense that we trust AI generated solution until we verify the solution. From that to a different approach that we don't trust the solution until it is proven to us that it's really working. And in order to do this, there's 3 rules that you need to remember. The first rule is taking advantage of writing the prompt. Prompt is always the best place to start with. Like you say, the more prompt, the more detail you provide to the AI, the better result it will provide to you, right? So treat your prompt as something like a Jira ticket, like a product requirement description, like a feature problem statement, and so on and so forth. Try to write it like the way you write a proper PR review. I'm not talking about the people who write PR with how say description with single line saying fix this bug. No one understands what fix this bug or fix the timeout bugs. It's not descriptive enough. So you need to write it with a full spec, with a lot of more detail, more specifications. Treat it like the way you write a spec for your feature. So if you cannot describe the logic in normal English, just don't ask the AI to write the code for you. It's like consequence. If you get lazy with the prompt, the result you get is also lazy code, and you don't want that. So make sure that the prompt is well defined, have all the detail that you found, like even if something that you think that can be useful for the AI, the context, the constraints that it may knows in order to provide better code, give it. Otherwise, you will end up with code that is too generic and may not fit your circumstance. Second rule is to make sure that you follow your gut to delete. That is my golden rule, by the way. If you look at the code that generated by AI and then you saw a block of code, or a line of code that you couldn't understand why it's there, what it does there, then you know what? Delete it. It may look good. It may have the very nice comment. It may be true, maybe not. But if you don't understand it, there's no reason to keep it because you don't understand it. You cannot explain it, which means you don't fully own that code. And if you don't own it, you cannot maintain it. So don't keep it there. The same way, like I always talk to my peers and my teammates whenever I review the solutions that generated by AI. That okay, so why is here? Why are we returning for 3 and not for 4? Why the bugs before also return for 3 and it doesn't work, and now you return for 3 and it works? What is this course doing here? In the end, we did return for 4 and we did a code according to we did figure out that it was just hallucinated and gave us the wrong answer. But if we just follow the AI generated code blindly because it fixed the bug, then we may miss out. And then when it break again, we just don't know why it break. And you don't own it, you cannot fix it. And you cannot fix it, you cannot explain it, you cannot own it, then why is there? Right? Rule of thumb. And the last rule is rubber ducking, but it's not the normal rubber ducking where you explain to the duck your code in order to find bugs. And you actually do the opposite. So you ask the AI to explain the logic back to you. So you acting like a duck, and the AI acting like the developer who try to explain its logic, so that you and him will do pair programming and find where that it may break. So ask it to explain to you why it works, what based on what assumption it's doing this, and if it see anything that it can see that may affect by this code, as is as much detail as possible as AI to explain to you in the plain English step by step, as simple as possible. And if it still doesn't sound like logical and transparent, but it sounds like magic or some kind like a black box to you, then the code probably not good enough, and the code probably have some bugs, and you shouldn't just accept it. Because you know what? We already talked about it in the previous chapter. Engineering is not about output. It's not about fixing bug only. It's not about shipping the code fast. It's about responsibility and intent. The AI can provide the output for you, fast code, fast solution, but you are the one who responsible for the result of the AI and whether the solution is accepted or not. Don't get these two mixed up. The AI is not responsible for what it generated. You are responsible for what AI generated. And that concludes my opinion of the day for this episode. AI doesn't make engineering easier. It make it harder now that because we are no longer a builder. We are no longer the one who authoring the code. We become the auditor, the curator, where we have to look into things with more experienced eyes, more careful eyes, in order to make sure we don't miss any crooked bridge that can make our system collapse. And being a good curator or auditor usually means that you need more knowledge, not less, which means you still need to practice your technical skill. You still need to understand architecture. You still need to understand your own system, and you cannot skip it. Cannot AI won't be able to learn it for you. You have to learn it by yourself. Otherwise, the longer we work with AI, the longer we have our system, the harder for you to be able to take full control and full responsibility for what you build. And with that, tell me about your story. What are the most confident mistake that AI ever gave you recently in any question, any prompt that you asked it? And if this episode resonate with you, follow me with be with my podcast on Spotify or Apple Podcast or even my YouTube channel. And we're going to spend more and more time discussing about how we align our engineering expertise as senior developer with the whole AI innovations going around us and keep our standards strong. Stay skeptical, keep building, and remember, just because making it fast, being able to deliver fast doesn't mean that it's always the right choice. See you in the next episode.